is we'll be shifting left 1, down 2, stretching vertically by 2, and reflecting. So our function in blue, instead of looking like a log function like this, it's been reflected. It should look something like this. We're going to start by graphing log base 3 of x, though. So log base 3 of x, if there's no shifts, no stretches, nothing, we know that logs have an x-intercept at 1, 0. When x is 1, log base 3 of 1 is 0. And then when x is 1, log base 3 of 3 equals 1. So you're getting good at evaluating logs. When x is 3, f of x is 1. If you know your powers of 3, log base 3 of what will equal 2? Log base 3 of what will equal 2? Niner. Okay. Our asymptote is the y-axis. And let's just add one more point. When x is 1/3, y will be negative 1. 1/3, 1/3, negative 1. From there, let's transform it and graph our parent function. We know it should look like this shape. H equals negative 1. We're shifting left 1. So there's our asymptote. It's a good place to start. Transform it just like we transform all our other functions. We take the y-coordinates of these 4 points in red and multiply the y-coordinate by negative 2. And then we go left 1 and down 2. So let's start with the intercept here. Y is 0. 0 times negative 2 is 0 still. Left 1, down 2. Left 1, down 2. The point at 0, negative 2. This point here at 1/3, negative 1, the y-coordinate is negative 1. Times negative 2 is positive 2. So now I'm at 1/3, positive 2. And then left 1, which is we go to 1/3 minus 1 would be negative 2/3, and then down 2 at the intercept. Do that one more time. This point is at 1/3, negative 1. Negative 1 times negative 2 is positive 2. So I go up to, I went to the wrong spot. Let's do that point again. Good thing we're doing it again. Negative 1 times 2 is positive 2. So 1/3 up to 1/3, 2. Left 1 should be at negative 2/3, 2, and then down to negative 2/3, 0. I did do it right. Huh. That reminds me of that one time I made a mistake. Or I thought I made a mistake. Did I tell you guys about that?
No.
You sure, McCain? I haven't told you about that? One time I thought I made a mistake. Turns out I was mistaken. Yeah. Let's go with this point. The y-coordinate is 1 times negative 2 is negative 2. So at 3, negative 2. Then we go left 1 and down 2. Should have a point at 2, negative 4. Last point, y-coordinate is 2 times negative 2 is negative 4. So now at 9, negative 4. Left 1, down 2. Should have a point at 8, negative 6. Okay. Again, our shape should look like this. So in this direction, approaching the asymptote. And here, going through these points and then leveling off as x approaches infinity. Okay, so our domain, our asymptote's at -1. So domain from -1 to infinity. Again, these are both parentheses. Range, always bottom to top, -infinity to positive infinity. From left to right, always from left to right, see our function is decreasing. So it's not increasing, it's decreasing throughout the whole, it's decreasing throughout the whole domain, which reminds me, I think I made a mistake on the last graph, didn't I? I did. Shoot. Check your notes. The last function we did, what did I put down for increasing? That's bogus. Someone should have corrected me. Last function, the domain was 3 to infinity, correct? And it increases throughout its whole domain, so it should be increasing 3 to infinity, not -infinity to infinity. That was a mistake on the last one. That was a mistake on the last one. So it's correct. It's decreasing the same as its domain, -1 to infinity. X-intercept, we found that point when we were graphing -2/3, 0. Our y-intercept we also got 0, -2. No horizontal asymptotes. Vertical asymptotes, x equals -1. Make sure that x equals. If you just put -1, that's not good enough. Oh, one more thing. It's what? March now? Getting close to April? I'm still seeing students write their intercepts as just like, oh, just -2/3 or just -2. Thou shalt write intercepts as points or ordered pairs. Always. No max, no min. This function is 1 to 1. Yes.